All right, so 9-5 is introducing and graphing the next couple of functions. So we've already talked about our secant and our cosecant being reciprocal. So what would that look like on the graph? Well, as you can see, cosecant is below our sine and secant is below our cosine. And if you notice, even though they look very different, they're actually closely related. So if you notice our sine, we have our points at 0, 1, 0 for that first quadrant. And then, if we go backwards, we end up with -1 and then 0 again. So if I were to take my sine and draw it on my cosecant, something interesting happens. So here's the same points that I had from before, and I'm just going to connect the dots. And as you can see, if you will, the maximum of our sine and minimum of our sine are connected to our cosecant. And so that is how we have a reciprocal graph cosecant. And the same thing is going to happen for our cosine. So we have our points at sort of -1, 0, 1, 0, and then -1 again. So if I were to copy that down on the secant graph, and I were to connect my dots, well, it would look like something like this. And so the same thing happens again. For our maximum, it is connected to our cosine, or our secant is connected to our cosine. For our minimums, our secant graph is connected as well. So that is how these graphs are related. And then tangent just follows its own sort of rules. Tangent just sort of does its own thing. But the thing with tangent that you should always remember is that it always goes through the origin, 0, 0. And then cotangent, we always have a asymptote at 0. And so for those of you who forgot what an asymptote is just an imaginary line where the graph can never cross. It can never touch it. It can get really, 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 really close, but it can never touch it. All right, so here are some basic properties of the trig functions, and I've included a lot of extra information, again, just to make sure that when you see this in the future for college algebra, you are not blindsided, you're not confused, you've seen it before, hopefully. The thing with this is you have to make sure that you understand that I threw in some basic formulas. For example, we have our x-intercept right here. Our x-intercept, it follows positive or negative n times pi, and you have to understand that we are assuming that n belongs to, that's what the symbol means, an integer, or that n is an integer. Remember, integers are going to be positive and negative whole numbers, including 0. So that is the assumption, and as you can see, that n, it pops up everywhere, because it's a nice way to sort of have a general idea of what is going to happen and stuff. And so beside the basic information, I went ahead and I included some pertinent information that's going to help us in the next little bit. So for example, I have over here next to the tangent and to the cotangent, which is what we're going to be really focusing on right now, I have that our x-intercept is typically going to be 0 and positive and negative pi. And our asymptote is going to follow the formula positive or negative pi over 2 times b. So whatever number is in our b value, that is going to be our piece that we're going to use. And then below that, for our cotangent, we have the same idea. Our x-intercept is going to follow pi over 2b. Remember, it's not going to have 0 because that's where our asymptote is. And so our asymptotes for cotangent, and this should say comma 0, but it should be pi over b comma 0. So we're going to take these same properties and we're going to apply them to our next example, which says to identify the asymptote, the period, and the x-intercepts, and then to sketch the graph. So that's what we're going to do, and I strongly recommend that you separate these two pieces of paper and have them sitting side by side, so that way you don't have to keep flipping your papers. Alright, so example 1.1 says identify the period, asymptotes, and x-intercepts, and then sketch one period of the graph. Use the graph paper, so you can click on this link. It's a new graph on the Desmos application, so you can change it and manipulate it and double check that your work is correct. I will say that it will not give you one period, it'll give you the whole graph. So it's going to be slightly different than what we're going to put on our paper, but it is the same thing. So the first thing we're going to do is we're going to check our period. The period is going to follow the formula pi over b, and b in this particular case equals 3, so it'd be pi over 3. And so I know that we're going to have one complete rotation or one complete picture within pi over 3. All right, so then my x-intercepts, well, because it's a tangent, so this is going back and looking at our properties, because it's a tangent, I know that it should be 0 and then pi, or 0 and negative pi. But in this particular case, it says assume that n equals 1. So if you plug in 1, positive 1, then that would be 1 pi or just pi. So the next piece is our asymptotes. Our asymptotes are going to follow the formula positive negative pi over 2b. So we're going to plug in that 3, and 2 times 3 is going to equal positive negative pi over 6. So now that I have all my pieces, I'm going to go ahead and put it on my graph. Remember, asymptotes are those imaginary lines, and so all of my information needs to be inside of my two asymptotes, which is going to be positive and negative pi over 6. So I'm just going to take my calculator really fast, and I'm going to figure out, well, what is the decimal of all this? So I have pi over 2. If I take pi over 2, pi divided by 2, pi divided by 2, that's going to give me 1.5. So I'm going to try to get a little bit smaller. Pi over 4. That gives me 0.78. Technically, if I round, 0.79. So I have the two values of pi over 2 and pi over 4. So I'm just going to quickly figure out, well, what is pi over 6 as a decimal? And I'm going to ask myself, is it closer to pi over 2 or is it closer to pi over 4? It's actually smaller than pi over 4. It's 0.52. And so I know that if I'm going to be putting a asymptote, the asymptote has to be smaller than pi over 4. All right, so I'm just sort of gonna guess, and I'm gonna say it's about here, and I'll put that this is pi over 6, and then I'll go the same exact amount the opposite way to negative pi over 6, because remember, our asymptote is positive or negative. So I'm gonna draw a line at these 2 points. All right, it's not very straight, but we'll get over that. And now that I have this, I'm going to go ahead and put my other pieces of information. I have my x-intercepts. Make that a little bit more obvious. Okay, so I have my x-intercept, which is going to be 0 or pi. Well, pi is not even inside of my asymptote, so I don't have to worry about it. I just have it at 0. So here is my x-intercept. And then the next piece that I can do, because I know it has to follow that sort of like that picture that we had before, you can think about I guess you can say turning points are going to be at the even with your quote-unquote amplitude. And I know that tangent doesn't really have an amplitude technically, but we'll say that our turning point is going to be at the halfway mark between our x-intercept and our x-intercept and our asymptote. So if I were to go between pi over 6 and 0, technically it'd be pi over 12, but our picture's really, really small, so I'm just gonna eyeball it, but I'm gonna put my point at 2. All right, so because that is my amplitude, 2. All right, so I would say that about halfway between the x-intercept, the red dot, and the asymptote, the green line, is about here, and notice how it is at the 2 if we were going by ones. And so I'm gonna do the same thing the opposite way, all right, but this time I'm gonna go down. All right, this way, when I draw my line, it is going to now follow a tangent shape. Okay, so that is how we do this, all right? And so the example 1.2 is the same idea. It's just, it's also going to be a little small. So after we're done with this one, we'll definitely do one that's a little bit wider and a little bit easier to read. All right, so same thing is happening with this one, except now we're looking at cotangent. Cotangent follows different properties. than our tangent, so we have to make sure we sort of get in our cotangent mode. But the period is the same. It's just going to be pi over b, which in this case is pi over 4. All right, so our x-intercepts is going to follow the formula pi over 2b. All right, so if we plug in pi over 2b, that's going to be pi over 2 times 4, which is going to equal pi over 8. And then our asymptotes are going to follow positive or negative pi over b. So I'm going to say equals pi over 4. All right, so now that I have that, I actually have pi over 4 as a tick mark on my graph that I provided. So I'm going to go ahead and just put my, it's also at 0 because it's cotangent. So we have 0 and pi over 4. 0 and pi over 4. My bad. Remember, with your asymptotes for cotangent, you should always have 0 as one of your asymptotes. So now we have to put all of our pieces in here. Now remember, I'll get to that in a second. So let's put our x-intercept. Our x-intercept is at pi over 8. That is just halfway between 0 and pi over 4. So it's going to be right around here. Let's make it a little bit darker. And then we are going to put our halfway mark. So again, our amplitude, quote, quote, is 2. So I'm going to have my point halfway between the red dot and the green line. But this time, I'm going to make sure that my curve is the opposite way, because if you notice, tangent sort of goes off to the right, the cotangent goes to the left. So I'm going to have my higher side to the left of the red dot, and I'll have my lower side to the right of that red dot, that x-intercept. And now that I'm done, I can connect my 2 lines, and that is that. All right, so let's do 2 more examples to make it a little bit, to solidify everything. All right, so in the next couple of examples, same idea. We are going to find our period of our cotangent of 1/2 x onto the left. And so our period follows the same thing. It's always pi over b. Plug in that 1/2, pi over 1/2, and it's going to equal, since you have a fraction in the denominator, the reciprocal happens, and so you end up with 2 pi. X-intercepts, we are working with tangent, so that's going to be pi over 2b, and b again is that 1/2, so it's going to be pi over 2 times 1/2, and 2 times 1/2 is just going to equal 1, so pi over 1 is just pi. Asymptotes follow the formula pi over b, and I actually went ahead and put my x-intercept right there. Pi over b is our asymptote, and so we plug in that 1/2 again. Our asymptote is going to be 2 pi. So I'm going to go ahead and 0. And so I'm going to go ahead and put my asymptote lines on 2 pi and 0. So I know all my information has to be in between these 2 lines. So the next piece I have to look at is, well, what is my turning point going to be? And since there is no amplitude or a value, I know that it's going to be an understood 1. So I'm just going to find the halfway point between my x-intercept, which is the red dot, and the green line, which is my asymptote. And I'm going to put a corresponding orange point there to represent my turning point, if you will. And remember, it's cotangent, so that means that the left-hand side is going to be higher than the right-hand side. So my halfway point is going to be pi over 2, and it's at 1. And then the opposite way is going to be 3 pi over 2. Again, it's going to be at -1. And so just to show you that these are equal with 1, and so, or quote, I guess you could say a amplitude of 1 is not really an amplitude though. And then we can draw a picture. So I just sort of connected them first so I can sort of see what it's going to look like, and then I am extending the arrows. So this is our graph, or our sketch of, I guess it's not a sketch. Sketch is way less detailed, but this is our graph of this particular function. All right, so then switching over back to a tangent mindset, we have a period, which is a little bit different than we've worked with, but I just wanted to show it to you. Pi over pi is equal to 1. All right, so remember pi is 3.14, so now we have just 1 to deal with, which is not even on our function, so we're going to have to work with that in a minute. All right, our x-intercepts is going to be 0 and pi because we're working with tangent. It's consistent. So I'm going to put my point at 0 because that's typically what it's going to be. My asymptotes is going to be positive or negative pi over 2b, so positive or negative pi over 2 pi, which is positive or negative 1/2. All right, so I'm just going to take a calculator really fast and figure out, well, where is our value going to be? If you take pi over 2, it's 1.5, and if you take pi over 4, it's 0.7. So because of that, we know that our asymptote line has to be between pi over 2 and pi over 4. So pi over 2 is the second tick mark. So pi over 4, and it looks to be like it's closer to pi over 4. So I should have my asymptote right around here. And this will be, actually, technically these are supposed to be written with a dotted line since they're asymptotes. So I'm just going to put this here and put a dotted line. I've been doing a straight line just so that you can see that all of our information had to be between it. But now that we're used to that, I'm going to go back to what we're supposed to be doing, which is having a dotted line. All right, so then I can take my my final piece, which is to figure out where is my turning point going to be. Our turning point, actually, I have mistakenly graphed our period and not our correct asymptote. So I'm going to actually fix that really fast because our asymptotes are actually at positive and negative 1/2, and 1/2 is going to be actually below the 1 pi over 4. So this is negative 1/2 and this is positive 1/2. All right, so let me fix that really fast. So our asymptotes are just a little bit further in. And again, I'm going to do the dotted line since that is typically how asymptotes are portrayed. All right, now that I've fixed that, I can go ahead and do my turning point. My turning point is going to happen at 4. It's between my red dot and my green line and its tangent, so that means the right-hand side is higher. So here is my point. On the right-hand side, it's higher. It is halfway between, or as best as I can, halfway between my red dot and my green line, and I know the quote-unquote turning point is going to be at 4. And so the same thing is going to be done to the left-hand side, except now it's the lower piece. And once I'm done with that, I can now connect the dots. So there is this, and that is our answer. So just to make sure that we are sort of solidifying everything that we have, I do want to summarize a couple things. The first thing is that when you have a tangent line, some properties that occur consistently is that your asymptote is going to be half of your period. It's half your period. All right, and then the other thing you should know about tangent is that your x-intercepts are always going to be, or typically going to be, 0 and pi. Typically, though, you are only going to put in the pi piece of information, or not the pi, but the 0 piece of information. All right, and then finally, our cotangent. The common things that occur for cotangent functions are that your asymptote is typically equal. It is equal to your period, and your x-intercepts are half your period. All right, so that's just some notes that you can sort of, after you're done with your work, after you're done using the formula, you can sort of double check, okay? Is your asymptote half of your period? Is your asymptote equal to your period? You know, depending on if you're working with tangent or cotangent. So things like that, you can just quickly check to make sure that you did it correctly. If all matches up, then you really don't have to double check your work. Again, I strongly recommend that you use the graphing ability that I have attached to this screen. I've attached to this homework assignment, or notes, excuse me. So please make sure you're using that to sort of see what is happening, and make sure you have the correct function highlighted. I had some students who were they were adamant that I was wrong on a problem, and then come to find out they had sine picked instead of cosine. So please make sure you are making sure that you have the correct function highlighted to be seen. All right, so then the last example is going to be something we've done before, which is transformations, and we're just describing the transformation of a graph from its parent function. All right, so the final example is describe the graph of g as, yeah, I made them all g's, good for me. Describe the graph of g as a transformation of the graph of its parent function. So this is just describing what transformation is happening. So in 2.1a, we have 2 secant of x. This is going to be our a position, so it is a vertical stretch of 2. And then in the next one, off in 2.2, we have the 1/2, which is a vertical shrink of 1/2, because this is just our straight value. All right, and then the other piece we have in this problem is that pi. Now it is our B position, which is our horizontal, and this one you have to flip. So if you think about pi being 3.14, if we do 1 over pi, well, that's going to be 0.3 something, 32 or something. That is now a shrink, so that's why that happens. All right, and then the letter B's, I'll let you guys do letter C's, just like I am letting you do for example 1. We have just our B value 3 in cosecant 3x in 2.1b. That is a horizontal shrink, because you have to flip it, of 1/3. All right, and then finally in the last letter B, you have that 1/4 in front, so this is a vertical shrink of 1/4. All right, so that is it for this section. I hope that you guys are doing well. If you have any questions, please reach out to me and ask me your questions, and I'll tell you no lies. I'm so funny. Okay, have a good one.